In these two problems, we will be finding the domain of each function. So for this first problem, we want to find the domain of f of x, given f of x equals 2x minus 3 over x squared minus 16. When you're finding the domain, there are two things to look out for. Denominators, in this case the x squared minus 16, and also square roots. If a problem only has a fraction, meaning a denominator here, then that's the only thing we need to worry about. When you're finding the domain, you're going to take this denominator and say that it cannot be equal to 0. Whatever values we find here cannot be plugged into the original problem. So we're going to solve each one of these. So to solve it, we could use the square root property or factoring. I'll just use factoring to make it pretty quick and simple. Since this is a difference of squares, this will factor into x minus 4 times x plus 4. And we're setting that result equal to 0. You can use an equals or does not equals. Either way, we're saying this cannot be equal to 0. And now we're going to set each of these terms equal to 0, because when you have something completely factored, each factor can be set equal to 0 if the entire multiplication is equal to 0. So we get x minus 4 equals 0. And x plus 4 equals 0. And if we add 4 to each side, that'll cancel out this negative 4 here, leaving us with x equals positive 4. Likewise, to cancel out this positive 4, we'll subtract 4 from each side, which gives us x equals negative 4. So when x equals 4 or negative 4, the denominator will equal 0. But we can't have that. For a domain, that's impossible. That means we would have division by 0 when x is equal to 4 or negative 4. So we say that our domain is all real numbers except these two values. Meaning if we take all real numbers, negative infinity, all the way to positive infinity, and remove these two choices, then we would start at negative infinity and we'd go all the way until the first one comes up, which is negative 4, and we'd say that that number cannot be included, so we put a parenthesis with it rather than a bracket. And then we put a union sign to say that this is continuing, and we're going to pick up right where we left off at that negative 4 and continue until the next break in our number line, which occurs at positive 4. Positive 4 also will not work. All the numbers between negative 4 and positive 4 will work though. And now we put our union sign again and pick up where we left off at 4. And we will go all the way to positive infinity this time. This value tells us all numbers except negative 4 and positive 4 will solve this problem, meaning we can plug them into the problem. So this is our domain. Okay, now moving on to this one. When you're dealing with a square root rather than a fraction, whatever is inside the square root has to be positive or 0. You cannot take the square root of anything less than that, otherwise you get imaginary numbers. So we're going to immediately take this negative 3x plus 9 and say that this has to be greater than or equal to 0. No matter what we do, negative 3x plus 9 has to be a positive number or 0. So if we begin solving for x, we'll subtract the 9 from each side to get negative 3x is greater than or equal to negative 9, and then dividing each side by negative 3 to get the x alone, we'll get x and positive 3. Negative 9 divided by negative 3 is positive 3. And because we divided by a negative, we have to flip the inequality, meaning this will become x is less than or equal to positive 3. And these are the only numbers that will work for our domain. These are the only numbers for which that square root will have a positive or 0 plugged into it. So to write this as an interval notation for the domain, x is less than or equal to 3 means every number less than 3 works, all the way until negative infinity. And everything up to and including the 3, because of the equal sign, will work. So we'll say all the way up to 3, but with a bracket because we can include 3. And this represents the domain of the original problem.